today I'm going to talk about naming ionic bonds, and before you do this, you need to make sure that you understand how to write formulas using ions, because we're going to be doing some of that in this video as well. So the first thing you're going to do when you're naming an ionic bond is you're going to write the cation. And if you remember when we talked about oxidation number, the charges on the left-hand side of the periodic table are going to be the positive ones. So cations are going to be the positive charges, and those are the elements that you'll find on the left-hand side, or any element or compound of elements that has a positive charge. The anion is going to be the thing that has the negative charge, and of course they're going to be on the right-hand side of the periodic table. And when you write the anion, you're just going to change the ending of that to IDE. So we will do an example. And the example we're going to do is a bond between magnesium and oxygen. So the first thing you're going to do is write the formula. And the formula here is going to be a bond between magnesium, which is in group 2, so that it has a charge of +2, and oxygen, which is in group 16, has a charge of -2. You'll crisscross the charges, and you will get MgO. And it would be Mg2O2, but the 2's cancel out. And so now we need to name it. So my first element was Mg. That is my cation, which is magnesium. So I'm just going to write its name, just like it is on the periodic table. And then the second element I had was oxygen, which is the anion. Instead of just writing oxygen, I'm going to change the ending to IDE. So it will be magnesium oxide. And that's it. Ionic naming is pretty simple. But of course, this is chemistry, so there's always exceptions to the rule. The first exception is with polyatomic ions. Polyatomic ions are just a list of elements that are bonded together, and those elements that are bonded together have a charge. So there are always going to be 2 or more elements, and they are always going to have a charge. And this chart is from page 7 of the North Carolina reference tables. So the way you recognize a polyatomic ion is that you have a formula that has 3 or more elements. So when you have 2 elements, that's just going to be a normal ionic bond. When you have 3 or more capital letters, that's going to be evidence of a polyatomic ion. And when you have polyatomic ions, which you recognize by those 3 capital letters, you do not change the ending on the anion. So if the polyatomic ion is the anion, you're not going to change the ending. If you look at the list, the first element up here is a cation, not the element, but the first compound. The rest of them are all anions. So anything down here, you're not going to change the ending on. And you'll notice that most of them do not end in "ide." There's 2 exceptions. Cyanide ends in IDE, as well as hydroxide. But the rest of those are going to end in something else. So that's another way for you to identify them. And we'll do an example here. So this time we are going to bond lithium, and the polyatomic ion that you are going to have is nitrate, which is NO3, and if you look at that list, it has a -1 charge. Lithium has a +1 charge, so I'll cross the charges and get LiNO3. Now I want to name this. So my first element was lithium, and then I have this polyatomic ion. I can tell it's polyatomic because I have 1, 2, 3 capital letters. So that means this is going to be my polyatomic ion. If I look on the list, NO3 is going to be nitrate. I'm going to not change the ending and leave it just like it is on that chart. And that is it. So pretty simple still, not too complicated. Make sure on these you leave the ending like it is. And then the other exception that you'll see with ionic naming is with transition metals. So this is exception 2. And if you remember, transition metals are the elements that are right here in the middle of the periodic table. And they're the ones that we said were hard to predict their oxidation number. So the reason that transition metals have an exception is because we're going to have to include the charge. And the way we do that is we use Roman numerals. So we're going to use Roman numerals to show the charge. So here's what I mean by that. Our example is going to be a bond between copper and fluorine. So copper and fluorine. If you look on the periodic table, fluorine's oxidation number is -1. And if I want you to use copper, I'm going to have to tell you the charge. So I'm telling you that the charge on copper is 2. Now I'm going to take those and crisscross them like normal, and that's how I get my formula of CuF2. Now I want to write the name. So I'm going to write the name of Cu, which is copper. Then I'm going to use parentheses, and inside those parentheses I'm going to include the charge. And then I will have my second element, which is fluorine. But I'm going to change the ending to IDE, just like I was doing earlier. So I need to include that charge. Remember, numbers down at the bottom are amounts, and numbers up at the top are charges. So the charge on copper, when we first crisscrossed, was 2. And that's what's going to go inside those parentheses. So now I want you to go the other way. I'm going to give you the formula. Let's see, vanadium 3p5. I want you to figure out the name of this. So I already said the first element was vanadium. And vanadium is a transition metal, which means we're going to need to include the charge. So you can leave parentheses there to remind yourself. And then the second element you have is phosphorus. So that will become phosphide. Just to point out, the transition metals are always going to be the cation. So when you're looking for them, it's always going to be the first element that you'll have. It'll never be the second element. So you're always going to change that ending. And then we need to figure out the charge on vanadium. So what we're going to have to do is we are going to have to uncrisscross. The number 3 comes up, and that number 3 actually came from phosphorus. Whoops, minus. Sorry. And then vanadium has a charge of 5. And if you look at the periodic table, phosphorus is in group 15, and group 15 has a charge of -3, so that totally makes sense. And so vanadium would be a charge, charge of 5. And that's pretty much it. And so that's ionic naming.